Hello students, in this video we'll be seeing the solutions for previous year JEE questions. So the first question is, a particle of mass m with an initial velocity ui collides perfectly elastically with a mass 3m at rest. It moves with a velocity vj after collision, then v is given by. So what happens before collision is you will be having a particle of mass m which goes with a velocity ui and collides with a particle at rest which is having a mass 3m. This is before collision, whereas after collision what happens is the particle collides and it moves with velocity vj, and the particle which was at rest with a mass of 3m moves with velocity v1. Okay, so now from momentum conservation you know that the initial momentum will be equivalent to the final momentum, so pi is equal to pf. So the initial momentum is p is equal to, you will be having mv. So here the velocity is ui, so you will be putting it as ui plus, since the mass is at rest, so the velocity will be 0, so you will be having it as 3m into 0. Why 3m is because the mass of the particle is 3m, equivalent to m. Here the velocity is vj, so mvj plus 3m v1. Okay, so on solving this you will be getting it as v1 equal to ui minus vj divided by 3. Okay, so now you take the modulus of this, you will be getting it as root of u square plus v square by 3, or you take the square root of this, you will be getting it as u square plus v square by 9. Okay, now since the collision is perfectly elastic, both the kinetic energies will be equivalent, so you will be having ki is equal to kj. Now you are going to substitute the kinetic energy here, so it will be half m u square plus half m 0, because the particle is at rest, equivalent to half m v plus half 3m v1 square. Okay, so now if you solve this, you will be getting it as u square equal to v square plus 3 v1 square. Okay, so you know v1 is u square plus v square, so you are going to substitute here u square equal to v square plus 3 by 9. So on solving this you will be getting v is equal to u by root 2. Okay, so the correct answer is option 4, v is equal to u by root 2. So it's a very simple problem, just you have to analyze the conditions, what is before collision and after collision, and you're going to equate the moments based on the momentum. You're going to equate the initial momentum and the final momentum, and since it's an elastic collision, both the kinetic energies will be equivalent, so you're going to equate both the kinetic energies before collision and after collision. The next question is, two identical strings x and z made of same material have tension Tx and Tz and their frequencies are 450 Hz and 300 Hz respectively. Then the ratio of Tx by Ts is. So here the frequency is given by f is equal to 1 by 2l root of T by mu. Okay, so here they have said that both the strings are identical. So for identical strings what happens is both the length and mu will become same. So f will be directly proportional to root of t. Since both the strings are identical, the length and the mu value will be same. So now what you are going to do is f will be directly proportional to root t, so you're going to take the ratio of that. So here for tx the frequency is 450 and for ty it is 300, so it will become root of tx by ty. Okay, so if you solve this square root, what you will be getting is tx by ty will be 9 by 4. Okay, so if you solve this, you'll be getting it as 2.25. so the correct answer is option 3, 2.25. Okay, so we'll move on with the next question. When radiation of wavelength lambda is used to illuminate a metallic surface, the stopping potential is V. When the same surface is illuminated with the radiation of wavelength 3 lambda, the stopping potential is V by 4. So if the threshold wavelength for the metallic surface is n lambda, then the value of n will be. So you know the general formula, Hc by lambda is equal to Hc by lambda naught plus Ev. Okay, so here they have given it as it is when the same surface is illuminated with radiation of wavelength 3 lambda. So the same thing will become Hc by 3 lambda equal to Hc by lambda naught plus E into V by 4, because what happens is the stopping potential becomes V by 4. So this will become V into V by 4. So you're going to multiply 4 on all either sides. What you will be getting it is 4 Hc by 3 lambda equal to 4 Hc by lambda naught plus Ev. Okay, so you're going to substitute that Ev value here. So from this you will be taking the Ev value and you are going to substitute here. So this will become 4 Hc by 3 lambda equal to 4 Hc by lambda naught plus Hc by lambda minus Hc by lambda naught. Okay, so if you solve this, you will be getting it as minus Hc 3 lambda equal to minus 3 Hc by lambda naught, or still if you solve this, you will be getting it as 9 lambda equal to lambda naught. So this is your n value. So this will become n is equal to 9. So the correct answer is n is equal to 9. Okay, we'll move on with the next question. Interference fringes are observed on a screen by illuminating two thin slits 1 millimeter apart with a light source lambda equal to 632.8 nanometers. So the distance between the screen and the slits is 100 centimeter. If a bright fringe is observed on a screen at a distance of 1.27 mm from the central bright fringe, then the path difference between the waves which are reaching this point from the slits is close to. So here they given you like this. You'll be having a screen and two slits. Okay, S1, S2, and this is the distance between the two slits, and this is the distance between the slit and the screen. So this is 100 centimeters or 1 meter. Okay, so you're getting a bright fringe over here. So this distance from the central maximum is y. Okay, so here what they've given is they have given you the d value, distance between the slit and the screen as 1 meter, and the distance between the two slits as 1 mm. Okay, so you know the formula, y is equal to nd lambda by t. So lambda also they given, it is how much, 632.8 nanometers. Okay, so n will become yd by d lambda. Okay, so you know the value of d, small d and lambda, and you also know the value of y. So here they are given the value of y is 1.27 mm, so it is 1.27 into 10 power minus 3 meters. So you're going to substitute it here, 1.27 10 power minus 3 into 10 power minus 3, because this is 1 mm, so 1 into 10 power minus 3 meters, okay, divided by 1 into lambda is 632.8, 10 power minus 9. So if you solve this, you'll be getting the value of n around 2. Now the path difference you have to find out. So the path difference you have to find out. The path difference del x equal to n lambda. So del x will become 2 into 632.8 into 10 power minus 9. So this will become 265.6 nanometers, or you can say it as 1.27. So it's around 1.27 micrometers. Okay, so the correct answer is option 1, 1.27 micrometers. Okay, the next question is the stream of river is flowing with a speed of 2 km per hour. A swimmer can swim at a speed of 4 km per hour. What should be the direction of the swimmer with respect to the flow of river to cross the river straight? So here if you see, what they are saying is a stream of river is flowing with a speed of around 2 km per hour. So here if you see, if he is trying to cross from this side to the other side, so you will be having this angle as theta, and this is the river speed, and this is the opposite direction, Vs sine. Okay, so this is the speed of the swimmer, which is Vs. So to cross the river straight, what happens is Vs sine theta should be equal to Vr, or sine theta equal to Vr by Vs. So here what they have given the condition is the speed of the river is 2 km per hour and the speed of the swimmer is 4 km per hour. So this will become 2 by 4, or it is 1 by 2. So here if you take the theta as 30 degrees, that is if you solve this, sine inverse of 1 by 2 is theta is 30 degrees. So the direction of the swimmer with respect to the flow should be equal to 90 degree plus 30 degrees. So this will become 120 degrees. So the correct option is option 3. Okay. Okay, so we will move on with the next question. A uniform cable of mass m and length L is placed on a horizontal surface such that its 1/nth part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, the work done should be. So what they are saying is, they are having a table like this, and they are placing a uniform cable. So some part is being hanging like this. Okay, so if you want to move this, how much work has to be done? So length of the hanging part is length of hanging part is L by N, and mass of hanging m by n. Okay, and then weight hanging part is mg by n. Okay, so let's see be the center of mass of the hanging part. So the hanging part can be assumed to be a particle of weight mg by n at a distance L by n below the tabletop. The work done in lifting the tabletop will be equivalent to the increase in its potential energy. So W will become mg by n L by n. So this will become W equal to mg L by n square. So the work done in lifting that part will be equivalent to mg L by n square. So the correct option is option 2. Okay, so now let us move on with the next question. In Young's double slit experiment, the path difference at a certain point on the screen between the two interfering waves is 1/8 of wavelength. The ratio of the intensity at this point to that at the center of a bright fringe is close to. So here what they've given is the path difference. The path difference del x is equal to 1/8 of the wavelength, so lambda by 8, and the phase difference del pi will be equivalent to 2 pi by lambda into del x. Okay, so del pi will become 2 pi by lambda into lambda by 8 because del x is lambda by 8. So you will be getting the del pi value as pi by 4. So at any point intensity I will be given by I max cos square del pi by 2. Okay, so you are going to substitute it here, I max cos square pi by 8, because this will be pi by 4 and the bottom will become pi by, on 2 is there, so it will become pi by 8. Okay, so if you solve this, you will be getting it as I by I max equal I by I max equal to 0.9238 the whole square, or I by I max 0.853. So the correct answer is option 2, 0.85. Okay, so the next question is the reading of ammeter for a silicon diode in the given circuit is. So they want us to calculate the ammeter reading for the given circuit. So you're going to apply Kirchhoff's equation here, and we are able to observe that the silicon is in forward biased. So 3 minus V minus I into 200 equivalent to 0. Okay, so as the silicon is in forward bias, the potential V will be equivalent to 0.7 volt. So this will become 3 minus 0.7 minus 200 I equal to 0, or 200 I is equal to 2.3. I will be equal to 2.3 by 200 is equal to 11 point into 10 power minus 3 ampere, or I is equal to 11.5 milliampere. So the correct option is option 2. So the current reading for a silicon diode in the given circuit is 11.5 milliamperes. Okay, so the next question is two masses m1 equal to 5 kg and m2 equal to 10 kg connected by an inextensible string over a frictionless pulley or moving as shown in the figure. The coefficient of friction of horizontal surface is 0.15. The minimum weight m that should be put on the top of m2 to stop the motion is. So here they have given you two masses m1 and m2, and they have also given you the tensions. Okay, and they are placing a mass over m2. So here m1 value is how much they have given is 5 kg, and m2 they have given it as 10 kg. So when a block of m is placed on m2, the motion stops and balances the tension. So both the tension becomes equal. So for m1, what happens is you will be having the mass here and the tension will be acting in the opposite direction, and here the force will be acting in the opposite direction, m1g. Okay, this is for m1. Whereas for m2, what happens is you will be having the force in this direction, the tension in this direction. This one will be m2 plus m into g, and here you will be having the friction, which will be opposite direction, which will be acting in the opposite direction. So the friction force F will be given by mu n, and here they are given the mu value as 0.15. Okay, so here they are given the friction coefficient as 0.15. So here F will become 0.15 into m2 plus m into g. Okay, so here the friction should be greater than or equivalent to the tension. So you'll be having 0.15 into m2 plus m g greater than or equivalent to tension, and this tension is given by m1 g. So you'll be having it as 0.15 m2 plus m g greater than or equivalent to m1 g. Okay, so since m1 is 5, you can substitute the values here, and you know the m value is 10, so this will become, sorry, m2 value is 10, so 0.15 10 plus m to g equal to 5g. So g and g will get cancelled, so if you solve this, you will be getting it as 0.15 m plus 1.5 equal to, so on solving this, you will be getting it as m is equal to greater than or equivalent to 23.33 kgs. Okay, so this option is not there in the answers, so we can take the nearest value as 27.3 kg. So the correct answer is option number 1. Okay, so we'll move on with the next question. A parallel plate capacitor of capacitance 90 picofarad is connected to a battery of EMF 20 volt. If a dielectric material of dielectric constant K equal to 5/3 is inserted between the plates, the magnitude of the induced charge will be. So here they have given you the parallel plate capacitor like this. So you are having the voltage over here, and you are inserting a dielectric material between the two parallel plate capacitors. So one is charged positive and another one is charged negative. So this dielectric constant, they have given it as K. Okay, so for a parallel plate capacitor, Q value is given by CV. So the initial charge Qi, this is without inserting the dielectric, will be 90 picofarad into the voltage will be 20 volt. Okay, so this is the initial charge, which is equivalent to 1.8 nanocoulombs. Okay, when the dielectric is inserted, what happens is your C will become Kc, which is a multiple factor of the dielectric constant. So your Q will become Kc into V. Okay, so this will become 5/3 into 1.8 nanocoulombs. So on solving this, you will be getting it as 3 nanocoulombs. So the induced charge, so this is QF, actually the final Q of the final charge. So after inserting the dielectric, so the induced charge will be QF minus QI. So this will become 3 minus 1.8, which is equivalent to 1.2 nanocoulombs. So the correct answer is option 4. So on inserting the dielectric material, the magnitude of the induced charge will be 1.2 nanocoulombs. Okay, we'll move on with the next question. Two batteries with EMF 12 volt and 13 volt are connected in parallel across a load resistance of 10 ohm. The internal resistance of the two batteries are 1 ohm and 2 ohms respectively. So the voltage across the load lies between. So we want to calculate the voltage lying across the loads. So first we will draw the circuit diagram as per the question. This is E1 and this is R1, this is E2 and this is R2, and this is the resistance. Okay, so here they have given you the value of E1 as 12 volt and R1 as 1 ohm and E2 as 13 volt and R2 as 2 ohm and the resistance is 10 ohm. Okay, so the equivalent resistance of R1 and R2 is given by 1 by R equivalent equal to 1 by R1 plus 1 by R2. So your R equivalent will become one by R1. So it's 1 by R equivalent equal to 1 by 1 plus 1 by 2. So this will become 3 by 2, 1 by R equivalent, or R equivalent will become 2 by 3. So your R equivalent is 2 by 3 ohm. Now you have to calculate the EMF equivalent. So EMF equivalent is given by E equal to E1 by R1 plus E2 by R2 R equivalent. Okay, E1 is 12 divided by R1 is 1 plus E2 is 13 divided by R2 is 2 into 2 by 3. So if you solve this, you will be getting it as 12.33 volt. Okay, so you have got the E equivalent. Now you have to find out the voltage drop across R. So voltage drop across R is given by VR equal to E equivalent R divided by R equivalent plus R. Okay, so this will become 12.33 divided by R equivalent is 2 by 3 plus 10 into 10. So if you solve this, you will be getting the VR value as 11.57 volt. Okay, so the correct answer is option 1. So it is lying between 11.5 and 11.6. So the answer is 11.57. So it is lying between 11.5 and 11.6. Okay, so we'll move on with the next question. A granite rod of 60 centimeter length is clamped at its middle point and is set into longitudinal vibrations. So the density of granite is 2.7 into 10 power 3 kilogram per meter cube, and its Young's modulus is 9.27 into 10 power 10 Pascal. What will be the fundamental frequency of the longitudinal vibrations? So here they have given you the Young's modulus value as 9.27 10 power 10 Pascal, and they have given the density rho value as 2.7 10 power 3 kilogram per meter. Okay, so the length they have given it as 60 centimeters, which is equal to 0.6 meters. Now the velocity of sound is given by V is equal to root of y by rho, so which is equivalent to root of 9.27 10 divided by 2.7 into 10 power 3. So if you solve this, you will be getting the value as 5.9 10 power 3 meter per second. So the velocity value is 5.9 into 10 power 3 meter per second. Now you are going to find out the fundamental frequency, which is given by mu is equal to V by 2L. So this will be 5.9 into 10 power 3 divided by 2 into 0.6. So if you solve this, you will be getting the answer as mu as 5 kilohertz. Okay, so the correct answer is option number 4, which is 5 kilohertz. Okay, so we'll move on with the next question. A telephonic communication service is working at a carrier frequency of 10 GHz. Only 10% of it is utilized for transmission. How many telephonic channels can be transmitted simultaneously if each channel requires a bandwidth of 5 kHz? So what they are saying is 10% of 10 GHz is used by the channels. Okay, so channels are using 10% of the 10 GHz. So it will be 10 divided by 100 into 10, which is equivalent to 1 gigahertz. Okay, so each channel requires about 5 gigahertz. So it will be number of channels 1 gigahertz, that is the frequency which is used for transmission, divided by how much they require, 5 gigahertz. So if you solve this, you will be getting it as 2 into 10 power 5. So the number of channels is 2 into 10 power 5. So it's a very simple problem. Just you are going to understand the question, and in the question they have given us 10% of 10 gigahertz is being used for by the channels, and they have also told like how much a channel requires. So it requires only 5 kilohertz. So by substituting it, you will be getting the final answer. Okay, so this is kilohertz, not gigahertz, it's kilohertz. Okay, the next question is, a man grows into a giant such that his linear dimension increases by a factor of 9. Assuming that its density remains same, the stress in the leg will change by a factor of. So here they are saying like a man is growing into a giant, and they are telling us to calculate the stress. So by a factor, how much it is varying. So if you see, stress is generally given by force per unit area. So here stress is force per unit area, and we are considering as force per L into B. Okay, now we are saying that the dimension is increasing by a factor of 9. So your new L will be, L dash will become 9L, and your B dash will become 9B. So your new stress S dash will become F by L dash into B dash. Okay, so it is F dash by L dash into B dash, which is equal to F dash by 9L into 9B. Okay, so now you are going to take the ratio of this. S dash by S is equal to F dash by 9L into 9B into, again here, L into B by F. So L will get cancelled, B and B will get cancelled. Now the force, you all know, F dash is equal to mg. Okay, so here you know density is mass per unit volume, or mass is density into volume. So here you can take it as F dash equal to rho V G, and since here F dash it is varying by a factor 9, so it will be, the volume will be 9 cube, so 9 cube rho V G. Similarly F will be rho V G. Okay, so you are going to substitute it here. S dash by S is equal to 9 cube into rho Vg divided by 9 square rho Vg. Okay, so these two will get cancelled. So S dash will become 9S. So the stress in the leg will be changing by a factor of 9. Okay, it is changing by a factor of 9. So the correct answer is option 1. Okay, the next question is, the moment of inertia of a uniform cylinder of length L and R radius about its perpendicular bisector is I. What is the ratio of L by R such that the moment of inertia is minimum? So given here, they given the length of the cylinder as L and radius as R, and I is the moment of inertia. Okay, so you know the general formula, I is equal to m r square by 4 plus m L square by 12. So if you take the m by 4 outside, what happens is it will become r square plus L square by 3. Okay, so here V is given by, V is equal to pi r square L. So if you substitute the r square value there, you will be getting it as I is equal to m by 4 V by pi L plus L square by 3. Okay, now you are going to differentiate di with respect to L. So di by dl is equal to m by 4 minus v by pi L square. It's a normal differentiation technique, okay, by 2L by 3. So for maxima and minima, you need, like for minima you need di equal to 0. So this will become m by 4 minus v by pi L square plus 2L by 3 equal to 0. Okay, so for minima it will be like di by dl equal to 0, so we are equating it to 0. And now, so like v by pi L square equal to 2L by 3, or you can take it as like v by pi L is what? V by pi L is r square, so it will become r square by L 2L by 3, or L by R equal to, or L by R is equal to root 3 by 2. So the ratio of length and radius is equivalent to root 3 by 2. So the correct option is option 1. The next question is, in Young's double slit experiment, slits are separated by 0.5 mm and the screen is placed 150 cm away. A beam of light consisting of two wavelengths 650 nanometers and 520 nanometers is used to obtain interference fringes on the screen. The least distance from the common central maximum to the point where the bright fringes due to the both the wavelength coincide is. So here they are saying it as n1th fringe, which is formed due to the first wavelength lambda 1, and n2th fringe is formed by the second wavelength lambda 2. So here they given the value of lambda 1 as 650 nanometers and lambda 2 as 520 nanometers, and small d they have given it as 0.5 mm and capital D is 150 centimeters. Okay, so they are saying is like the fringes will coincide and their distance from the common central maximum will be same. So since it is same, you will be having y n1 equal to y n2. So it will be n1 lambda 1 d by d1 equal to n2 lambda 2 d into d. Okay, so if you solve this, you will be getting it as n1 by n2 equal to lambda 2 by lambda 1, and you know the value of lambda 2 is 520 and lambda 1 is 650. So your n1 by n2 ratio will be 4 by 5. Okay, so the distance of the point of coincidence from the central maximum is given by y is equal to n1 lambda 1 d divided by d equal to n2 lambda 2 d divided by d. So you are going to substitute in this formula. So you know the ratio of n1 by n2 is 4 into 650 into 10 power minus 9 1.5 divided by 0.5 10 power minus 3. So if you solve this, you will be getting the answer. So if you solve this, you will be getting the answer as 7.8 mm. So the correct answer is option 2, 7.8 mm. Okay, so we'll move on with the next question. Arrange the following electromagnetic radiations for quantum in the order of increasing energy. So they are given it as A blue light, and B is yellow light, C is X-ray, and D is radio waves. So as you see the electromagnetic spectrum, you know that the energy is directly proportional to the frequency. Okay, so when the frequency is increasing, the energy also increases, but energy is inversely proportional to the wavelength, because E equal to hc by lambda, because mu is c by lambda, so it become inversely proportional to the energy. That's why if you see radio waves will be having a larger wavelength in comparison with the gamma rays, but gamma rays will be having a higher energy in comparison with the radio waves. So here the order of energy will be, so the least one will be D. So your radio wave will be having a lesser energy, your radio wave will be having a lesser energy in comparison with the yellow light, because yellow light is coming over here, which is around in the range of 600 nanometers, in comparison with the blue light, which comes over here in this region. So blue light means A, which is still lesser than in comparison with the X-rays. So this is the order. So the correct option is option 2, DVAC. So your radio waves is having a lesser energy in comparison with the X-rays. So X-rays will be having a larger energy when compared with other 3 wavelengths of light. So the wavelength is less for an X-ray, but the energy will be very high because of the relation E equal to hc by lambda. Okay, so now we'll move on with the next question. Radiation of wavelength lambda is incident on a photocell. The fastest emitted electron has a speed v. If the wavelength changed to 3 lambda by 4, the speed of the fastest emitted electron will be how much? So they want us to calculate the speed of the emitted electron. So the kinetic energy of the emitted electron is given by E equal to hc by lambda minus pi. So here lambda is the incident wavelength and pi is the work function of the photocell. So it will become half m v square equal to hc by lambda minus pi. So in the second case, the incident wavelength is increased by 3 by 4. So your incident wavelength will become 3 lambda by 4. So here your energy will become E2 will become 4 hc by 3 lambda minus pi. So you can see in comparison with E1 and E2, E2 seems to be greater than 4 by 3 of E1, because this is E1, you know that. Okay, from this you can see this is E1, so 4 by 3 of E1. Similarly, your velocity will be V2 will be greater than V of 4 by 3 to the power of half. So the correct option is option number 2, where the velocity is greater than V into 4 by 3 of half. Okay. So next we will move on with the next question. A uniform string of length 20 meter is suspended from a rigid support. A short wave pulse is introduced to its lowest end. It starts moving up to the string. The time taken to reach the support is, and here they have told us to take G value as 10. So uniform string of length 20 mm is suspended from a rigid support such that the time taken to reach the support will be given by T is equal to mg x by L. So velocity at a point P is given by root of mg x by L divided by m by L. So your velocity will become root of gx. So you know the dx by dt is equal to root of gx. So you are taking dx by root x equal to root of g into. So now we are going to integrate it. So 0 to L dx by root x equal to 0 to t root of g dt. Okay, so here L is 20. Okay, so you can take it as 0 to 20 dx by root x 0 to t root of g dt. If you integrate this, you will be getting it as 2 root of x 0 to 20 equal to root of 10 into t, because g you are taking it as 10. So if you solve this, you will be getting it as 2 root of 20 equal to root of 10 into t. T is equal to 2 root of 2 seconds. Okay, so the correct answer is option number 4, 2 root of 2 seconds. So the time taken to reach the support is 2 root of 2 seconds. Okay, so next we will move on with the next question. An arc lamp requires a direct current conversion of 10 amperes at 80 voltage to function. It is connected to a 220 volt 50 Hz AC supply. The series inductor needed for it to work is close to. So they want us to calculate the inductance. The resistance of the lamp given by Ohm's law is given by R is equal to P by I. So which is equal to 80 by 10 is equal to 8 ohms. Now when an inductor is connected in series and source is applied, what happens is your voltage will become V equal to Iz. So V will become I root of R square plus omega L the whole square. Okay, so here they given you the current as 10 ampere for lamp to work. So it will become 220 equal to 10 root of your R value is 8. So 8 plus 2 into pi into 50 into L the whole square. So when you are trying to solve this, you will be coming to a value of L is 0.065 Henry. Okay, so the inductance value is 0.065 Henry. So the correct answer is option 1. Okay, I think this video would have been useful for you for solving the problems in JEE. So I wish you all a good luck, prepare well for your exams. Thank you.